Hey everybody, this is your review on 5.1 to 5.2. So on this one, you have f of x equal 4x squared, and you're going from 0 to 14. So there's a couple of things to mention. The first is for the lower sum. What the lower sum means is that if you have your rectangles, they are below the curve. And when they're the upper, that means they're above the curve. And so in each case, they're going to be a little bit off, which is why later in the lesson we like midpoint better. Okay, so for your one with two rectangles, and we're going 0 to 14, that means that your delta x would be 14 minus 0 over 2, because it's two rectangles, which gives you 7. So for the lower with 2, we need to use f of 0 and f of 7. So this would be 4 times 0 squared, which is 0, and 4 times 7 squared, which is 196. So add those, so your sum equal 196, then multiply by delta x, which is 7. So 196 times 7 gives you 1372. Okay, so that's for the first part. Now with lower, with 4, we're going to use those same two, which we've already computed, so we don't need to redo it. But we also need two more. So think about the middle between these would be like 3.5, and 7 plus 3.5 would be 10.5. And just do what we did earlier, 4 times the number squared, and so that gives you 49 for this one and 441 for this one. And so then your sum is 686. Now whenever it's 4 rectangles, you have a delta x that's half as much as that one. So that's going to be 7 over 2, which is 3.5. The other way to think of it is if you do 14 minus 0 over 4 rectangles, again, you get it the same way. So here we have 686 times 3.5, and that gives you 2401. So on your lowers, the most important thing is you start with f of 0, and you should not use your final endpoint, which is 14. Now on your upper with 2, this time we're going to use, well, first off, it's the same delta x as we did earlier. So for the 2 rectangles, it's 7. For the 4 rectangles, it's 3.5. And this time you're using f of 7, which we said was 196, and f of 14. So f of 14 would be 4 times 14 squared, which gives you 784. So then you add these two numbers together, and that gives you, let's see, 196 plus 784 times 7, that gives you 6860. And on the last one, you have your delta x is 3.5. We're going to definitely use f of 7 and f of 14 and not use f of 0. So don't use f of 0. So that means we need to go to 10.5, which we said earlier was 441. That's why this is easier on paper if you just see your numbers. And f of 3.5, which we've already said is 49. So now your sum is 1470, and you do 3.5 times 1470, which is 5145. So that's basically how you go about that problem. Now on the next one, you're doing f of x equal x squared, and you're going from 0 to 2. So again, start with your delta x would be 2 minus 0 over 2 rectangles, because we want 2 rectangles to start with. So that gives you a delta x of 1. And the most important part about this one is the key word is midpoint. So what that means is if we have rectangles that are between 0 and 2, that means 1 is here. Well, what that means is that your midpoint would be 1.5 and 3.5, or 3 halves. So those are the midpoints. So when you're doing f of the number like you did up here, you're not going to use your boundaries. You're going to use the midpoints. So your f of 1/2 is 1/4, because it's 1/2 squared. And you do 3 halves squared, which is 9/4. So this time you do your sum, that gives you 10/4, which is really 5 halves, and then 5 halves times 1 is 5 halves. So that's this answer. Now for 4 rectangles, we're going to have delta x equal 2 minus 0 over 4. Again, the reason for the 2 minus 0 is that's what x is between. And so that gives you 1/2. So if we do a drawing like we did earlier, we're still going 0 to 2, but we need 4 rectangles. And so these numbers that we got earlier are actually boundaries of the rectangles, which means we need to use numbers smaller than that. Like in between here and here would be 1/4. I'm going to put 0.25, and between 1/2 and 1 I'm going to put 0.75, and between 1 and 3 halves I'm putting 1.5. Oh, that's 1.25 is what I really wanted for 5/4. 1.25 is between 1 and 1.5, and then this one is 1.75. Okay, so now that we have those, we need to do f of each of those. So f of 1/4, that's 1/16. F of 3/4 is 9/16. F of 5/4, I guess here I'm doing it as fractions, that doesn't matter. F of 5/4 is 25/16, and F of 7/4 is 49/16. So then you're just going to add up these numbers. So your sum is 84/16, and then you do 84/16 times your delta x, which is 1/2, and that gives you 21/8. So one of the important things to remember is your delta x is not from here to the midpoint. Your delta x is at the boundary for the rectangles. Okay? Alright, now for the next one, you're using 10-second intervals, and so that means our delta x equal 10. And what you're doing for this one, for the left endpoint, is do the sum of the velocity, but don't use the last term. So in other words, we'll say 10 times, okay, these numbers, stopping at 24. 0 plus 45 plus, and then there's, 45 plus 24. So add them together and multiply by 10. That gives you 3740. Now when you're doing this on Math Excel, make sure you're able to see your complete table like you are when we do this on paper, because sometimes a couple of values are chopped off and you got to move your cursor, move your mouse pointer. Okay, on this one, with the right endpoint, you want to do your sum, but don't use the first term. So basically you're going to use the sum, which is, this is how I would do it actually, since that was 0 and we knew this sum was 374. We're going to do 374 plus 38, find out what that is. And that gives you 412. And then 412 times 10 is 4120. So, excuse me. The reason why that works is because our first one was 0. Okay, for our next one, we want an upper estimate for when the speed is, or when the time is 4. First off, notice what your delta is, and in this case it's 1 because you're counting by ones. You want to use that this is decreasing, so basically it's coming down like that. Now what that means is it's really opposite of what we did earlier. So this time we need to use the left endpoints since it's decreasing, because your rectangles would be like that and you need to use your left endpoints. So your delta x or delta t is 1, and you're going to do 32 plus 19.41 plus 11.77 plus 7.14. So don't use the last. Okay, so when you do that, that gives you 70.32. And then for the next part, we still want to use 1, but this time you skip your first terms. You're going to use your right, so skip the first term. So you skip your 32 and you go 19.41, 11.77, 7.14, and 4.33. Add those together and multiply by 1, which is basically the same thing. So you get 42.65. Now the next thing, it wants an upper estimate again, but this time it says t equal 3. And how we have to go about this is the original table was time versus acceleration, and we need time versus velocity. And so at time 0, it's velocity 0. At time 1, it's 32. At 2, it's basically, this is how you do it. You do the sum of these, so 32 plus 19.41. And that's how you get 51.41. Then your next one is 3, and so we're basically going to add 51.41 plus 11.77. And so that gives you 63.18. Okay, and that's as far as you go because, you know, that's your time. So you basically add these three together, and so your sum is, well, I can put it over there, 146.59. So you're basically adding 32 plus 51.41 plus 63.18. Okay, on the next one, we want to do midpoints again. Okay, so again on this one we're using midpoints. We're going from 3 to 5, and we need 4 rectangles. Picture usually helps. Okay, so 4 would be right down the middle. And then 3.5, 4.5. 1, 2, 3, 4, 5. I just did 5 rectangles. Okay, so I need 3 to 5. The middle is 4.5. So that'd now be 2 rectangles. And I need to use the midpoint. Let's do my delta x first. 5 minus 3 over 4 gives you a half. Okay, so do this drawing over. I got distracted because somebody came in. I lost my focus. Okay, so 3, 4, 5 right there. 3.5 goes here. 4.5 goes here. That's what your rectangles are going to look like. 1, 2, 3, 4. Those are your 4 subintervals. Okay, so your midpoints are going to be 3.25, 3.75, 4.25, and 4.75. Okay, so now on this one, we're going to take our half and multiply it by 3.25 cubed plus 3.75 cubed, and so on. 4.25 cubed and 4.75 cubed. So when you do this, let's see, 2. when you do this, you get 135.5, but then you have to make it a fraction, which would be basically divisible by 2. 2 times 135 is 270, and then one more, so 271. So 271 over 2. Okay, on the next one, table is leaking at an increasing rate, and we need the upper limit with 4 hours. So on the upper limit, we skip the first term. And our delta is 1. So we're basically going to do 1 times 55 plus 150 plus all the way to 7, no wait, after 4 hours, stop at 330. And so when you do that, you get 775. For the next one, you want your lower, so that means you skip your last. So you're going to do 30 plus 55 plus 150 plus 240. So skip your last in the interval, which is the 330. Because we want 4 hours, so these don't even matter. Okay, so this gives you 475. Now this time we want the one for 8 hours, and so we do 1 times 55 plus 150 all the way to 720. That gives you 3095. And this time we want 1 and then 30, 55, and all the way to 640. And so that gives you 2405. Okay. So for the next one, if the leakage occurs at a constant rate of 720 gallons per hour after 8 hours, and it initially had 28,000 of material, what's the least amount of time? So this one, use the Math Excel setup, which would basically be 8 plus, because it's 8 hours, 28,000 minus the number associated with 8 was 3095. All of that divided by 720. So when you do that, you get 42.6, which is the right answer. So that's how you want to do it. Not like in the book problems under the workbook, it said do 3095 plus 720t equal 2800, and then you get 34.6. So that setup with it being linear is wrong. We need to use the Math Excel setup. So basically, they updated how you do this problem to this. So on the last part, we have 8 plus 28,000 minus, this time they want the lower. And so this would be the 2405 that you use. over 720. And when you do that, you get 43.5. Okay. Now let's move on to the summation questions. And so these are like what's on 5.2. So the thing to notice about this is it says write it without sigma notation. Don't evaluate it on the first blank, but you do want to on the second blank. So basically we just want to sub in. So basically you're going from 1 to 2, you put in 1 for here. So you're going to have 180 times 1 over 1 plus 8 plus 180 times 2 over 2 plus 8. So again, just put the 1's in and plus, then put the 2's in. And when you do that, you get 56. Okay, on the next one, which of the following expresses this in sigma notation? So I'll do one of these by hand, and then I'll use the calculator for the next. So by hand, you would say from k to 1, that means you have 2 to the 1 minus 1. So that's just going to be 1, because 2 to the 0 is 1. Whoops, not 20. 2 to the 0 power, which is 1. And then for the next one, you need 2 to the 2 minus 1. So that's 2 to the first, which is 2. And then 2 to the 3 minus 1. So 2 squared is 4. And so seeing that 3 of the numbers match already, that's a good indication it's going to work. Okay. So for the one starting with 1, what I usually do is I just do that by hand. This one actually looks easy also. We just want to do 2 to the 0, which is 1, 2 to the 1, which is 2, 2 squared is 4, and so forth. Again, that's going to match. But now on this one, just for variety, could use function 1 as 2 to the x plus 1 and start your table at x equal negative 1. So this technique is going to save you some time if it's complicated. Like this one's not that complicated, but some of them have 2 or 3 different parts, and so it's just variety. So we go to add graph and then say 2 raised to the x plus 1 power, and then just go to our table and start at negative 1. So there you can see 1, 2, 4, 8, 16. So one, 2, 4, 8, 16 is for 3. And so that matches also. All right, now for our next one. This time, we want to see which one works. Now, we know if it alternates sign that it's going to have a negative 1 here. I think on this one it's probably going to be easiest if we do this on the calculator. So, for example, negative 1 to the x power times, times 1 over x minus 1. So first off, just make sure you typed it right. Let's see, negative 1 to the x times 1 over x minus 1. Okay, it is. Now, it goes up and down a whole lot, but don't worry about that. We care about the table. and start the table at 15. And okay, so this one's going to be weird decimals. At 15, it's negative 0.07 something. At 16, it's 0.06 repeat. Let's just check those. You know, you can go to the value, then do Control C to copy it, and then Control V to paste it, and then convert that to a fraction. Okay, so this first one was really negative 1/14. So since the first one here is negative 1/16, that means it's not it. Okay, so let's change it to this. So if we go back to our current, Control T to get rid of our table, and we basically just change this to a plus, and look at our table, and this time we want to start at 16. Okay, this one gives us 0.05882, negative 0.055. Well, if we got a positive, then it's not it, because our first term should be negative. Okay, so now let's try the next one. Get rid of our table. And this time, get rid of the +1. Control T and start at 15. So this one is negative 0.06 repeat. Well, the 0.06 repeat we said already was, well, let's see, what is it? Control C to copy it, and then Control V to paste it. Menu, number, fraction. That's negative 1/15. So that didn't quite make it. Now we need to do the next one. And if I do +1 right there, now start at 15, that's negative 0.0625, and then positive 0.05882. Okay, so copy and paste. It's negative 1/16. And again, if I go to my table, copy this one and paste it. That's positive 1/17. And so that means we're on the right pattern, so that's going to be the right one. Okay. Now for the next one, you want to evaluate the sum. And so this one, using a linear formula. So that linear formula is n times n plus 1 over 2. The quadratic, and I'm not done with that problem, but that's like the setup. The quadratic formula is n plus 1, 2n plus 1 over 6, and the cubic formula is n plus 1 over 2 squared. Okay, well these are easy as long as you know that n is your endpoint. You don't have to really add all the terms. Use the formula instead of adding terms. So you're basically going to have 12 times 13 over 2. So that's basically going to be 6 times 13, which is 78. And on this one, you have 12 times 13 times, let's see, 2 times 12 is 24 plus 1. Okay, let's do a little bit of simplifying. 12 divided by 6 is 2, and 24 plus 1 is 25. So I want to do 2 times 13 times 25. That gives me 650. And on this one, we basically take this answer and square it, which is 6084. That's the most efficient way to do that one, since it's all lined up like that. Okay, so then for the next one, you got to treat it like it's a linear and do negative 12 sum k equal 1 to 8 of k. So that means you have to go negative 12 times 8 times 9 over 2. Just using the linear pattern, you know, because n is 8. So let's simplify it a little bit. Negative 6 times 72. That's negative 432. So 8 times 9 is 72. 12 over 2 is 6. Okay. So then for the next one, this time you're just going to do, well, there's no number, there's no letter, for this, so you're just going to do 5 times 7, so that's 35. On this one, you're just going to do 7 times 400, which is 2800. And on this one, you're just, okay, so those two were easy because they started at 1. This is the one that's a little trickier. It's probably the same thing as k equal 1 to 248 of 20. So what if we did 20 times 248? Times 248, and that's 4960, which is the correct answer. Okay, so if your starting point is not 1, you got to adjust it. Okay. And then for the last one, we just need to pick the one with the right rectangles. And for the left endpoint, that means that's going to be A. And for the right endpoint, it's going to be C. And for the midpoint, it's when it's sum above and sum below, which is B. Okay. All right, so just study those graphs, and that'll be it. Have a good one.